So, hello guys, today we will talk about buoyancy and I'll explain you how to create easy and simple one, not very complex, but it can actually make some pretty changes to your water for debris, small objects, for interactable objects, even for big pillars. But there are some issues with it and I'll explain it soon. So, as you can see from the picture here, the basic idea of creating buoyancy is to add the plane, this blue one, inside the water surface. Then, when an object is interacting with the water, we need to use two line traces. The first one here, we will trace from the bottom of our object, and it will always be the bottom, so even if the object is rotated, it won't be tracing using the up vector, it will always use bound extend z. When we subtract from our origin z this particular value, we will receive this type of point on our object. So the first instruction is for creating the ripples or the water splashes, and the second line trace is also from the bottom here, like this one, but the length of the line trace will be the length between the up surface of our water and the plane inside our water surface. So this particular area, this one. And when the trace hits this plane, it will return the position which we will use to create the sine or cosine wave with I don't really remember the words in English. So the power of sine wave will one moment guys, the power with time will be decreasing. The power will be decreasing over the time. So when the object is dropped into the water, it starts floating, and with time or over time the floating will be withdrawn and it will just be here. Well, the main problem with using such type of buoyancy is to select from which point we need to line trace. If we use the medium here, then our object, if it hits our buoyancy plane, let's call it this, will be always covered like 50 by 50. So at this point, this part will be visible from the water, this part will be inside the water. For objects that's like rubber, in case you need to visualize the rubber duck, when it's put inside the water, it should float here, like the upwards. It should not be inside the water here. So this trace from the center is prohibited. On your right here, you can see that we can actually create some sort of line trace from each vertex of our object. Each object is, even if it's sphere, is encapsulated inside the bounding box. Bounding box is just simple cube. Actually, this was my first implementation and it worked fine, but there was a problem when I started rotating the object. There is a very big issue So when you start rotating the object bounds don't rotate with you. They are just expanding. So if you have like looking right in front of you, object line trace are perfect. But when you rotate it 90 degrees, so from like this point it goes to this position, the line trace actually won't change its position. They change the bounds, so the difference between these points are increasing. So that's not an option. And actually, to achieve the proper vertex position of the object, you need to go inside every object in static mesh editor, then select CPU access, so you can use a node that will return the proper vertex position with the world rotation. And it's very complex decision for the feature that usually uses for some sort of interaction. I mean, you see the debris, they are floating, and that's all of the use cases. Well, if you don't create some sorts of Sea of Thieves or Assassin's Creed Black Flag where you use the buoyancy in a very complex way, this my method is pretty much suitable. Also, I figured that we need to one more issue with line tracing from this point here, from the bottom. If you use distance between this hit result and this position, the distance won't change. So even if you put an object on this side, like you see from this picture, it will be like standing still and won't draw into the water. So using distance is the worst option. You need to subtract the location from an impact from the position of an object in the world and use the operation which is called vector length. So if our object is changing our position, vector length will be changed over time. So if you put an object to rotate, it will start drawing. So the visual feedback will be more realistic. Well, I guess you understand the idea and the issues that I encountered while creating the buoyancy. So please take easy on me. And let's continue with our blueprints. Also, I'd like to notice that using this particular operation can be used to create some sort of floating movement for like drones inside some sci-fi game, and for hover bikes, hover cars, and so on. So let's continue. So also I'd like to notice that if you don't use my water or haven't seen my water tutorial, you can go and watch it. But if you don't want, actually this approach will show you the idea that you can implement without even implementing my water. So first of all, go to project settings and inside collision tab, you need to add object channel. It's called buoyancy for my purposes, and default response for it is ignore. So every object will ignore the plane with, or the object with this particular collision type, because we only need to trace along an object. We don't need to actually have physical collision for it. Once it's done, let's go inside the water and I'll show you where to put our buoyancy plane. So right now you can't see it. As you can see, I'm selecting it here, but nothing happens. That's because you don't need to have it visible. For this, you need to create some sort of material. I call it void. It's masked and unlit, so we use 0 in opacity mask, and as you can see, it's very cheap and it masks our object. So do this also. Then static mesh component inside the box, this one. This box is for the underwater effect. Also, we use it to check whether we are inside our water, and if it's so, if the object is fully covered with water, it should not make any splashes. So, box collision, buoyancy plane, scale, location, rotation, everything is by default. Material void to actually make it invisible, or I can show you how it looks here. This one, and some adjustments into the construction script. Also make sure that when you set your plane inside your box, you need to go to the collision tab and in collision preset set collision to be custom, object type to buoyancy, change collision enabled to query only, and that's it. That's all the setup for the buoyancy plane. Next, construction script. So, buoyancy level should be adjusted only inside this particular box. So if the length of the box is 100 units, changing this, the position of buoyancy plane should be equal. Like, for instance, here I have an attribute called buoyancy height. As you can see, right now it's 50. So if I, and it's in the world units. So if I check the underwater height, it's 100 units, and it's length of this particular bounding box. So if I change it to 50, you'll see it decreases, and now the buoyancy level is right on the bottom of our box. So if I change buoyancy height to 10, it's right up here. If I use it 0, it's right on our top. If I use 25, it's here. So that's the beauty of using the construction script and this simple logic. Also, make sure that the buoyancy height is actually not very small, because the amplitude, this one, for like making the object waving inside the water, well, if the height is small, the amplitude will be also small, and the object will have more artifacts. The transition between like floating will be very visible and will look unnatural and very speedy. So make sure that the buoyancy height is 50 or more units. Next, to the construction script. Here you can see changes from the last episodes of the water, and I'll show you what I've changed. So this part is for creating the infinite water plane on X and Y axis. This part is for creating the proper scale of the bounding box for the underwater effect. That's for relative location of our box, so it starts with 0 and goes beneath our water. And this one is for our buoyancy level. So buoyancy height, we add underwater height multiplied by minus 0.5 because the bounding box uses, so it should be like on the center of, well, I'm sorry guys, I'm a little bit sick, so it's quite hard to explain everything in a very speedy way. So in 2 words, this operation just makes our buoyancy plane to start from this point, like this one is 0 and this one is 1, like the gradient. And because the bounding box expands half size, we need to use this multiplier to perfectly start from this point to this point. So please do the same. So underwater height is the height of our bounding box. The buoyancy height is the position of our buoyancy plane inside our bounding box. So when it's done, we can continue with the water component. Water component is the component that can be attached to any object in the scene, like cube. All you need to is make it physics to simulate and add water component, and that's it. Now our cube can interact with our water. Also you can see that from this particular component added to our cube, here we have the attributes that can be changed to every object that use this component in the scene. These attributes are unique for each object, and you can actually simulate any behavior for any sort of your object. And this is just like the simple force that don't use the mass of the object. I found it more simple to understand how the behavior will, well, actually how to predict the behavior of an object. And linear and angular damping. So linear damping is for the straightforward movement from up to down, and angular for the rotation. The higher values is, well, the more difficult for object is to rotate or to change its position over the time. Now let's see what do we have inside our water component. So, water component. We actually have some changes here. Well, as you can see, that's pretty much the whole component in the work. Let me just quickly show you how it differs from the previous version of it. So as you can see, it has some more changes, but I'll explain you everything, so don't be afraid. First of all, we have event begin play, where I use getOwner of my component and set this component, its static mesh component, as the reference, which I call affected mesh. Also, if you have the object inside the water and it's not moving, it should not generate any waves. So for this, to stop generating any ripples, splashes and so on, I added the timer for the storing the previous position of my object. It loops every 1 second and it just generates its previous position and overrides every 1 second. I need this to check whether I have difference between positions, and if it's so, then I use generation for our waves. If the position is the same, we don't need to generate any splash. So that's so simple. So as you can see, event calls this event, this operation. Now on tick I check whether my order is actually valid. So if it's so, here is the first line trace for our object. And as you can see, I've changed the start and end operation, and it's the pure function, which is called compute trace. To create the pure function, you need to select pure here, so you don't need to have any exact pins. Here is what we had earlier. So we trace from the bottom of our object, even if it's rotated, every part of an object which is change the Z position will be like the point of our object. So it's better than using the up vector. Well, actually we need to use the distance by 1, so the trace for the generated waves, like for the object start interacting with the water, should be like only 1 unit to check whether we start interacting. So it's pretty simple. Then I check whether there was a hit result, whether we actually interact with the water. If it's so, we continue with our logic. If it's not, well, right here I have changed the linear and angular damping of my object. But this operation is for the object that is inside the water surface. So when it's not inside the water surface, I need to restore its default state. Like by default, angular damping is 0, linear damping is 0.01. You can create like visible variables and change it due to your needs. It's not the purpose of this tutorial, so for the sake of it, I just restore the default attributes. Next, also changes. I check whether I'm under the water. So if we are inside the water, like this, moving our object should generate waves. If we are up here or down here, there won't be any water ripples. So for this we need to check whether our top level, this one, is under the water. So it's also the pure function where I check bounds of my affected mesh, but it's up side, and check whether it's inside the bounds of the box of our interactable water, inside this one, and return the value. So if it's not inside, then I check like my previous location and current location of an object inside the water with like the error tolerance set to 5 units. So I find it like more accurate for me. This also can be used as the variable for every object you need to make unique movement inside the water. So if it's not under the water, I check this condition, and if it's false, so my location and my previous location aren't equal, I apply local splat. That's the waves inside the interactable water. Well, if it's true, so I just skip this part and continue with this one. Also, if I'm inside the water, my top level is like under here, I don't need to generate any waves, so I also go to our buoyancy. That's also one interesting operation. We start to line trace for object but for buoyancy, and the height of our trace is the height of our buoyancy inside the water. Like, we always trace this distance, even if our object here will go like to the bottom, we don't need to adjust it here. It will always like automatically check the proper distance for tracing. And the same operation, compute trace here, like we have it here. Next, we check whether we had interaction. If it's so, we set this result like buoyancy heat result, and add force, linear damping and angular damping to our object inside the water. Here is changes. Make sure that you have selected acceleration change, so it will be less confusing to actually modify also the weight of the object. You just need to change the force of applied to an object, and you can actually find it more easier to understand the behavior when you go from 1000 to 2000. You see the difference very sharply, and you can easily and quickly change it to like the behavior you want. Also, there is a function that I called compute buoyancy effect, and that's what you can use for any sort of floating movement. It's also pure, and it returns the force applied to our object. Here I use heat result and use location minus world location of our mesh. That's what I was talking about right in the beginning of the video. So you can use like distance here, but the distance won't change during the time. So your object, if it's pushed on the side, will actually look like this one. It won't draw. And it's not natural. So that's why I use this sort of operation, because changing world location and break result always during the time will change the vector. And vector length is used like the size of a vector. It also changes during the time, so the behavior will be more realistic. I divide it by buoyancy height, so that's how I achieve some sort of 0 to 1 gradient, and I use it to learn between my buoyancy force, and here I can go with this operation, and this will learn between like no force and full force during the time. You can go with this operation, and instead of using this multiplier, you can create the one and make it visible. So the behavior will go like, even if you have an object that is upside down, like its up vector is inverted, it won't draw like it will be floated inside the water, but not near the ground. It's like between the ground and the water surface. So somewhere here, not here. So this also can be changed. I'm sorry guys. So as you can see, with buoyancy force, damping, angular damping, also with this coefficient, you can achieve different behavior for any type of object. And once you've done it and test it, you will see that it's actually very easily to understand and make like different behaviors for concrete, rubber, to simulate some sort of wood behavior inside the water. Then I multiply this value by the impact normal, so I will receive the vector which will be applied to an object, so it will start like floating using the amplitude. And that's actually all for the buoyancy tutorial. I hope you understand what I have done here. If you try it, and I guess you will find it useful for many cases. It's not very ideal, but I'm waiting for the better like internal water realization of water inside Epic's Unreal Engine, but it's not ideal now, so that's why I use my custom implementation of water and water buoyancy. So please leave your feedback, subscribe if you like my videos, also make requests and I'll do like I guess almost 98% of what you want to achieve. And see you soon.